Thank you for the introduction. My name is Patrick, CISO and co-founder of Mondu. Previously, I built it up at SVA GmbH in Germany, a pen testing team. So we hacked hard and software and published also 0 days. During this time, I also established an incident response team, built it also up from scratch, did forensics, reversing of malware, and also ransomware negotiations. And yeah, transfer Bitcoin, Moneros, and the fun stuff. Let's look at what is the problem. Previously, as a hacker, we are like shown in the left. We are hackers, so we want to compare our skills, which person can hack smarter and better and faster. But that evolves to a completely business. That means the ransomware groups or the attackers are organized like a company. You have a managing director, you have an engineering department that are developing the attack tools and the playbooks. And you have an operations team that is executing the attacks against the company. And also they are following the playbooks, they are using the engineering tools from the engineering. And they do it also with DevOps stuff. So they have pipelining everything in place. So they are really like a company. They have to fulfill sales quotas. They have a customer support 24/7. I will show you later a little bit about that. The playbooks, so I was able to get one playbook from the Condi ransomware group within the darknet. So I will show a little bit some insights. And they have also affiliate programs and bug bounties for the attack tools and the ransomware as a service. So let's focus at first. That was from the Condi ransomware group. That was one of the largest and successful ransomware groups out there. So this playbook starts if the group has one entrance. One is the client or the server, or they have both maybe. And then the playbook starts. At first they are looking around. It's a little bit Windows heavy, but you get what they are doing. At first they are looking around which privilege they have, what they have, which user accounts, where are the domain controllers, where are the domain admins. Then they are looking for shares to identify sensitive information and also password lists, password documentations, whatever. Then you find the first Kerberos attack, because if they have the entrance, the first goal is to get the highest privilege within this company. That means in a Windows environment, it's a domain administrator. In a Linux environment, it's the root account. And for attacking the Windows environment, there are several attacks like Kerberos attacking. And here you will also see you have just to copy paste the commands and execute the stuff. So that's really a playbook for the operators. You don't really have to understand what is a Kerberos attack. You're just executing the stuff according to the playbook and compromise the whole company. Here you have Mimikatz. With Mimikatz, it's a pretty famous tool for pen testers and attackers to grab the credentials from a system, because if you're on the system, then you want to grab all the credentials that are on the system. That's in the Windows environment called NTLM hashes. Then exploit an unpatched vulnerability, zero logon. Again, just copy paste the commands, done. Maybe you have to adjust a little bit the IP addresses and some stuff, but that should be possible for every person. Then how to SMB brute force. And that was a really famous password that I found doing my penetration testing. You know exactly the password today. It's summer 2023 question mark or exclamation mark or whatever. That is really, and it follows the default password policies. So that's really famous, like summer, August, or whatever. So it depends a little bit on the policy, password policy within the company, but yeah. That is how users building passwords. SMB brute force. Again, how to exploit an unpatched vulnerability with a PowerShell script. Here, exploit XP and Windows 2003. here you have the Metasploit commands. Metasploit is a pretty famous exploitation framework for pen testers and attackers. Just copy paste and adjust the IP address ranges. That's it. Then this is all about that. How to scan for routers, because you want also to compromise the complete network infrastructure, that you can grab all the traffic and reroute to you or whatever. As an attacker, again, zero log on, unpatched vulnerability. Here you have the GitHub. Just download from the GitHub the attack code and execute that stuff. So you see, you don't have really to be an attacker or pen tester. You have just to follow the playbook, and then you get compromise the whole company. We had a competition in our at SVA. How fast we can enter or how fast we can get domain admin credentials if we first step in this company. And it took 5 minutes. Also it's between 5 and 15 minutes. If you have physical access to the building, 5 to 15 minutes, every company. Then about the anchors, the backdoors, Condi was using during this time AnyDesk. AnyDesk is something like TeamViewer or something like that. Just to install that, and also to install in a silent mode, that you don't have the icon at the bottom right or bottom left for AnyDesk or TeamViewer or whatever. They used also Atera for the backdoors. So it's a little bit different from group to group which backdoors they are using, but they are using normal tools, nothing else, because TeamViewer is not detected via an EDR. AnyDesk is not detected via an EDR because that's a famous administrative tool. No EDR, XDR solution will detect that. Never ever. Just download that. You don't have to obfuscate or do spooky stuff or some foo with that. Just download AnyDesk, install on the system, and no one will complain about that. Then hunting for admins in the Active Directory domain. Let's go just cross over because I want to show you some other stuff. Part 2. If you are interested in having this playbook, just come to me, I will send it to you. That you can play in your company. Just kidding. But if you want that, just email. Here you have the stage upload, because if the attackers get in your company, they want at first to exfiltrate all the sensitive information, financial statements, customer data, whatever, and then you get totally encrypted with the infrastructure, because you get you get pressure on to pay the ransom money because they are publishing your sensitive information, and that you don't have access to your data anymore to get the decryptor. And during this time they were using Mega.io, but other ransomware groups using like compromised Google Drives, Dropboxes, or whatever. And for that you use rclone. That's a nice little tool that can communicate with every cloud storage. Mega, Dropbox, Google Drive, whatever. And then you can also upload the stuff. And here you find also some nice comments, because you don't want to use the complete internet bandwidth of this company, because every administrator will jump out of the seat and say, what is the hell is going on here if some service is consuming all the internet bandwidth of this company. And with these commands, you are limiting the bandwidth, and also how much you are using from the internet breakout. That you get, that you are just using 10% that you get in the normal traffic of the day. That no one is questioning what is going on. If you just use 5% or 10% more from your internet bandwidth, no one is questioning. Maybe there's a new YouTube video out and all the employees watching that. Then the next stage and the last stage is lock. With this locker, you can encrypt Windows, Linux, and also E6i. That means you get encrypted on 2 layers. One is on the operating system layer, and one is on the hypervisor layer. That you really have to pay to get your, because the VM backup is also running on an E6i. So, and almost every company that I was pen testing, the backup server is also domain joined. So that means if you compromise the domain and you're a domain admin, you can encrypt it on the OS level and then again on the VM level, on the VMDK level. And this is the command. You execute it from the domain control, from the domain controller, and this command will send to every system that is a domain joined system the encryption command. And it takes 5 minutes, then you're totally encrypted, your whole company. It doesn't matter if you have 1 petabyte or something like that. Because they are not encrypting the whole file, they are just encrypting chunks out of that. And then you are screwed, because you cannot reconstruct the stuff. And here you find also some how to disable Windows Defender, Sophos, and such stuff. So it's pretty easy. Everybody that has a little bit of IT knowledge can just consume that and compromise a company. That is the reason why the operators are the cheap employees. They are sitting in India or in South America because you need cheap employees. And the engineering guys, they are really have the knowledge about all the writing the attack tools and the playbook. Oops. What the hell's going on? Yeah. So that means if you look a little bit or zoom out from the document, you notice why hackers or ransomware are so successful in compromising companies. There are 2 or 3 root causes here. One is unpatched vulnerabilities, and one is not hardening of your client server and applications or all your infrastructure. Hardening means apply a secure configuration to your environment. And that is also highlighted by this Cyber Signets report from Microsoft. And they tell us 80% of all attacks can be attributed to outdated software and misconfigurations. What we see at the moment is a little bit a budget misallocation. Let's focus at first on the NIST cybersecurity framework. Identify means get your asset inventory from your containers, Kubernetes, whatever it's running in your infrastructure. Protect means apply patching, hardening to your infrastructure. Detect means have a system in place that detects attacks from malicious actors. Respond to the attack itself and mitigate the stuff. And recover means recover to normal operations. Everybody is speaking about security incident event monitoring, EDR, XDR, MDR, malware, anti-malware, threat intelligence. That is all detect and response. And you have to invest in your patching and hardening of your infrastructure because that builds your foundation of your complete security. And also it's for me a little bit too late because we were able to bypass every EDR, XDR, Splunk, Curator, whatever, because that's a cat mouse game. We sharpen our tools, then the EDR solutions sharpen their tools and the detection algorithm, and then you go back and that's is a cycle. So half of the year we were able to detect bypass like Sentinel-1, CrowdStrike, all the big ones, Windows Defender, advanced threat protection from Microsoft, whatever. And then we need other half year because then they got better in the detection, and then we have to reinvent a little bit or to tune our tools. And for me, it's also too late to detect, because detect means you have an attacker in your infrastructure already. I don't want that. And also to highlight it a little bit more, what makes more sense? At the moment, we are seeing that you have open doors and you put a ton of cameras to monitor an open door. What? It's a little bit broken from my perspective, because just close and lock the fucking door. What is the problem with that? Okay, let's look a little bit of ransomware negotiations. If you got totally encrypted, you will find on every system a ransomware node. At first, you have here about what happened with your infrastructure. So that's the introduction of the ransomware group. We are Sodino Kippi, Conti, Lockbit, whatever. Then you have here the part how to contact them. And then you get your personal private key. This private key is because you go on a darknet website and put the key on that you get your personalized ransomware page. Because they are compromising in parallel a ton of companies, not only you. They are compromising or attack maybe 10, 100 companies in parallel, so they have to identify you. Then you get this nice little page here, and you see here the ransomware money. It's about 5 million. And they want to have it in XMR, that means Monero. That's a privacy cryptocurrency where you cannot see how the transaction goes through the network, and not identify the parties of that. And then you have this little nice counter here that will decreasing, and if it gets to 0, then it doubles your ransom amount to 10 million. That is the reason why, as an incident responder, you go into the company and ask, do you have backups? Then they are telling you yes. Okay, do you have access to your backups? Oh, maybe no. Okay, then we have to rush to go to them and start the ransomware negotiation because of that. Then they have also a little bit about us to give you some guarantees that you will get the decryptor, but remember, they are criminals, so that's not really a guarantee. We have our networks that we ask for in our forensic networks or incident response persons. Do you have any experience with this ransomware group? Do you know if they are legit? Is it just a scam or whatever? To find out if you really want to pay. Then you have a trial decryption. That means you are uploading an encrypted small image to this website that gets decrypted, and then you get the decrypted one and can show and prove, yeah, they still have the master key. Because every system has its own AES encryption key, and that will be derived or depends on a master key. And you need the master key to decrypt your whole infrastructure. Then you get here a little bit of advice where you can get the Bitcoins and the Moneros. And then you have the 24/7 chat support. This support is better than Deutsche Telekom. Okay, it's not a tough one, but it's possible. Then you negotiate the 3 main factors here. One, to decrease the ransomware amount. The second one, to get more time, because you have to onboard a complete company to an exchange where they are transferring 5 millions and get the Bitcoin or the Moneros or whatever. And the third one is switch from Monero or privacy coin to Bitcoin. Why? Because the market capitalization of Monero is so small. If you put 10 millions in this market, the price will skyrocket. That will go through the roof. That is the reason why you want to switch to Bitcoin, because the market capitalization is so huge. If you put 10 millions, you don't move the price. So then all the stuff is negotiated. Then you transferred all the stuff via the Bitcoin network. And then I ask for the universal decryptor. Here you will see the universal decryptor. It's an exa or a binary. You put it just on the system, double click or execute on the Linux shell or whatever, or the VMware E6i shell, and it decrypts in 10 minutes everything. And I was asking there, and then they told me, I think it will be soon. We are not robots. Our employees need sleep. As soon as someone shows up, they will make you your universal decryptor. Now you get also notice they are not speaking about my buddy, my friend, or something like employee. So then you get the favor. It's a complete company structure. And they have 24/7 support like a normal company. They have engineers. They have an 8 hours or 10 hours working day. And that's it. We got that. Then you go to the site, and then you can download the universal decryptor and decrypt all the stuff. And be friendly. Say thank you. So now we highlight a little bit of the problems, what is going on here. Now let's look at why we have to shift left. What you can see, if a 0 day gets published, because the 0 day is you identify that, then you register a CVE, it's still an 0 day. it gets to a public CVE or vulnerability if you publish that. And if you publish that, it needs, for a high or critical one, it needs round about 30 days maximum to get a working exploit code from a person. You will find that on the GitHub, in the darknet, whatever. But the average mean time of fixing a severity within a company needs 240 days. So that means most of the companies will be vulnerable to a misconfiguration or a patch for around about 200 days. Why is that? If you look at most of the companies, they have to identify that in the production. Then they are writing a huge report because they love documentation. I have no clue why. Then they're creating a ticket out of that. That ticket goes to the developer, and then it gets included in the sprint. It takes also time. Then a developer is looking and say, "Oh, you fucking security guy, I don't understand." Then it goes back, get another documentation, whatever, and then it takes round about 100, 150 days to get to the developer and really to start the fixing. And then the developer needs also some time to fix the stuff, to test everything and so on. And then it gets fixed, and then it takes also some time to roll it out. And that is the reason why you need round about 200, 240 days for the fixing stuff. But there are tools to scan the internet in 5 minutes for a vulnerability. Just 5 minutes. And if you have a normal DSL with 200 megabits per second in bandwidth, it's possible to scan the IPv4 range in 5 minutes for a vulnerability, because the ransomware groups do it in this way. They deploy it in the botnet, so they have compromised huge amount of PCs, of assets, and everything is scanning the whole internet every time, and they are scanning just for this one vulnerability, like a WordPress or Exchange Hafnium from Microsoft, the email server or something like that. Then they can scan that in seconds, and also the botnet is also tuned to automatically compromise that and get the initial access. And then it will pass to a pipeline or via email to the engineerings of the ransomware groups. Yeah, you have access there, and then, oh cool, I have such a list where I have access, and then they go via hand on that and put the operators on that. And also, that was a little survey. There was asked 1100 IT security professionals. 80% of them were victim of a ransomware attack last year, and 60% out of this 80 paid the ransomware money. So what you see in the press or normal, it's just the tip of the iceberg. It's also because I transferred round about every year 10 million or 15 million, something like that. So we didn't pay the 5 million amount. So let's look a little bit where's the problem between security and the developers at the moment. At first, you have different tools for the security. Most of the time they are using like Tenable, Rapid7, Wiz, Lacework, whatever, to scan the runtime, the production environment. But the developers using other tools, Trivy, Claire, whatever, to do the scanning there. Or maybe they are using OPA-Rigo for that, to have the compliance stuff, the policies. And right now, you have a red line between development and build and runtime. Because you have different tools, so you get a fragmented view on your complete development lifecycle. So you need an policy as code engine that shows you the complete, or you can apply these policies, runtime, build, and development, all the stages, that you don't get the fragmented view anymore. Because if you write down, because I'm not so I don't like the Word documentation. I like it more, put the stuff in a policy, what you want as a security, and give it to the developer, that he knows totally he has to develop against this policy, and just get the details what he has to do. So let's hack a little bit. I deployed an EKS cluster. It's just one node EKS cluster. It doesn't matter is it one node or 10 nodes or 100. And in this AWS cluster, I deployed a DEM vulnerable web application pod with one container, the DEM vulnerable web application container. That's the green one here. I deployed also an Kali Linux and attacker machine. On this machine, I run one web server that delivers two binaries. One binary is for the reverse shell of the container, and the second binary is for the reverse shell of the Kubernetes node itself. Because at first we are compromising via a command injection or remote code execution the DEM vulnerable web application. Then we use an unpatched vulnerability to gain root rights on this machine, because we need the root rights to perform a container escape to compromise the underlying Kubernetes node. Because if you as an attacker have the underlying Kubernetes node, every workload is also compromised on that. Here you see my Kubernetes 1 node. Here you see my pod. This is the web server that delivers the two binaries. This is listening for the container shell, for the incoming reverse shell. And this is listening for the Kubernetes node for the incoming reverse shell. And this is the web application. You have just to put ls in there, a semicolon and ls, and then you get listed the files and the folders on this machine itself. I will copy over some commands because with this command we are downloading from my web server the first binary and put it under temp met. Let's look at the web server here, that you see it in real time. Now the container goes to my web server, downloads the stuff. Open the container shell. Then we have to make this binary executable on the system. And execute the stuff. And hopefully everything goes well, and we will see the incoming reverse metaparator session. Now I can type commands like get UID, because I want to see which privilege I have. I have the privilege of www-data. That's an unprivileged user. Let's get a shell. Now I have a basic shell. Yeah, it's really basic. It's not like a bash that you are used to from a normal Linux system. Change the working directory. I will copy over some commands. I will describe it to you in a second. Oops. Or let's describe it here. I download from my S3 bucket the PawnKit vulnerability. PawnKit is a C++ code, and I compiled that for AMD 64. That means this privilege escalation is working on every AMD 64 architecture and Linux systems. Then this downloaded stuff, I make it executable in my binary, execute the binary, and get the shell. And now hopefully everything was working. Now I'm root. So that means I'm god of the system. Within the container I can do everything. Let's do the container escape. That's so small, maybe I describe it here. At first I'm mounting the C groups from the underlying Kubernetes node. Then I activate the on-release manager from the C groups. With this little command, I figure out where I'm living as a container, because every container per default is living on the Kubernetes node under var lib docker, and then a hash, and there is the whole file system of my container that is running. And I attach a little bit we create this new shell script cmd and save that in the release agent. The whole path, I save that in the release agent. Let's fill up my cmd shell script, the shebang, the curl command again to download the second binary from my web server, make it executable, run the stuff, and make my my new shell script executable. And with this $2 into C groups, I trigger the notification manager within the C groups, and this one loads the stuff that is saved in the release agent. And there is my path to my shell script, what I put the curl command in and so on. So that means here you see that the underlying Kubernetes node is going to my web server and downloading the second binary. Sorry for all the CLI stuff, but I'm really CLI heavy, sorry. And here you see the incoming connection, and now type ID. So I have root rights. Don't trust, verify, don't trust hackers. Let's verify. That is the host name. And here you see also the host name. So that means we're having root privileges, the highest privilege in this Kubernetes cluster. So we compromised all the stuff. What happened here? At first, I want to show you the deployment. Damn vulnerable web application deployment. Oops. That is a Kubernetes deployment manifest. Here I'm specifying which container I want to start. Also about which port I want to open for this container. And this is the misconfiguration because I started this container as a privileged container. In the past, that was necessary if you have a huge Kubernetes cluster with GPUs and want to run some AI algorithms. You needed raw access to the NVIDIA graphic cards for the CUDA engine to calculate your AI models. That's not anymore necessary because there are interfaces. But I still see that in some environments that they are starting privileged containers. And how you can identify some misconfigurations, I told you before, policy as code. So cnspec is an open source tool, and also the policy is open source, and you can run that on the CLI, and you can run it actively in your cluster as agent and agent based and agentless. It's up to you. And where is here? The container should not run as privileged container. That is the reason why we perform the container escape. Another reason why we get the root rights is in the container was an unpatched vulnerability. Again, we're scanning just the container. It's our open source. Come on, go. Okay, I didn't follow really the rules to create the container because the container is 800 megs big. So that's not really the best practices to create containers. That is the reason why it's so long to scan that stuff. Come on. Now. And here you see the vulnerabilities. And we use the polkit vulnerability to get the root rights. Where is the polkit? Here. This one. So, okay, we scanned it in production. So you can use the same policy and put it in the CI/CD pipeline. And then you get via JUnit output also, whoopsie, tests. The oh, it's so small. Wait a second. Tests, container scan. Also that you have unpatched vulnerabilities in your container. That means what I see in the production, I see it already in the pipeline. So I can block the pipeline if the developer don't fix the stuff or want to commit and manifest or and build pipeline with some vulnerabilities. And also I'm able to scan the manifest scan that I did on the CLI. I can put it also in the CI/CD pipeline. Let's search for here for the privileged container. That means that is the reason why you have to shift left. At first, you are much more faster and cheaper to iterate the stuff, and also you're reducing all the patching and the patching time and also the misconfiguration time, because as policy as code, the developer knows exactly what he has to do. Okay, 1 minute. Let's look a little bit about the policy. Just go to the GitHub. Where's the Kubernetes security? Privileged. Stateful. deployments. A privilege escalation. I don't want privilege escalation. I want privilege container. Oopsie. Come on, why am I not copying that? Damn it. And now you have policy as code, and the developer gets exactly what he has to do. Because the security context privilege should not equal true. And that is the reason why I'm more in about writing that as policy as code, as testable stuff, and put it into the pipeline, and don't write the Word documentations.